Hello dear student. Exercise 3.3. Question 1. Find the transpose of each of the following matrix. The meaning of transpose is converting the row into column and column into row. This is the meaning of transpose. So first question is 5, 1 by 2 and minus 1. This is written in the column format. This is written in the column format. So 5, 1 by 2 and minus 1. This is the now matrix for the this element. Same way for the second. So you can check. So this is the representation. Suppose A is the matrix. So A transpose we can write here 5, 1 by 2, minus 1. Second question, A equal to 1 minus 1, 2, 3. So this is the first row. This is the first row. And now this becomes the first column. This is the second row. This is the second column. Only transposing, only the element we are transferred from the row to column and column to row. This is the minus 1, 5, 6. So this is the first column, second row. Now it is second column, third row, 2, 3, minus 1, and this is the third column. Question number 2. A equal to this value, B equal to given this, we have to verify A plus B transpose, A transpose plus B transpose. So first of all, when we are adding these two, so we know how to do the addition of the two matrices. And after that, we have to check A transpose plus B transpose. Now, first of all, A is given, we have to find out A transpose and B transpose. After that, just doing the step, adding both the A plus B. So A plus B, first we have to add, then minus 1, minus 4. This is the corresponding 1 to 1 element adding. So this is the value of A plus B. So A plus B transpose is nothing but just we have to change minus 3 to minus 5. This is nothing but the first row, second row, third row. Now this become first column, second column and third column. Now A complement plus B complement. Whatever the complement value, just we have to add, and this already we know how to find out the addition of the two matrices. So A plus B transpose is equal to A transpose plus B transpose. Similarly, A minus B, first we have to find out A minus B. So whenever the transpose, when the two matrices is adding or subtracting, first of all, we have to find out the addition or subtraction of that particular value. And after that, we are taking transpose value. So A minus B, first we have to find out. After that, A minus B transpose, we have to take 3, 4, minus 3. This is the value in the first. This is the value in the first column. Now this is the first row. So just we have to interchange. Then this is the final result of A minus B transpose. After that, A transpose minus B transpose. This just we have to do. So similar type of question you can just do and verify. A transpose is given, B is given, then verify A plus B transpose, A transpose plus B transpose. It is known that A equal to nothing but the transpose of transpose value is A. Suppose any transpose value is given. If we will take the transpose, then we will get the result A. So A is 3, 4, minus 1, 2, 0, 0, 1. And B dash is minus 1, 1, 2, 2, and 1, 3. This is the value. So whatever the value of A is given here, so based on that, A transpose of transpose, if we will find out, then we will get that result. So this is A, this is B dash. So A plus B, this is the A, and this is the A value, and we have to add these two value. So A plus B is equal to this result, and A plus B transpose is this result. So this is the important question. Transpose of transpose is always the given matrix A. A minus B, first A minus B we have to find out, A minus B complement we have to find out, and A complement minus B complement. So this is the verified result. If A complement is minus 2, 3, 1, 2 and B equal to this, then we have to find out A plus 2B complement. So A plus 2B complement. So first of all, whenever the A complement is given, so we have to use this value. So this is very, very important. So A complement of complement is nothing but the A. So we required the result A. So first we have to find out the A value. After that, we have to find out the 2B. 2B we have to find out, and A plus 2B complement we have to find out. So this is the way. For the matrix A and B, verify AB transpose equal to B dash A dash, where this is a given value, A and B is this value, second A and B is this value. So first question, first we have to find out the AB, product of AB we have to find out. So AB value is nothing but this is the A and this is the B, and this is 3:1 matrix and this is 1:3 matrix. So this is nothing but the multiplication rule. This is matching and the result is nothing but the 3:3 matrix. So this is nothing but the result is 3:3 matrix. So in the multiplication matrix, this is very, very important. So we know how to do the multiplication. Just we have to multiply one by one this one. So 1 into minus 1 is minus 1, 1 into 2, after that 1 into 1. In this way, we have to take one element from here and we have to multiply this. After that, for the second row, we have to find out minus 4 into minus 1, minus 4 into 2, minus 4 into 1. After that, 3 into minus 1, 3 into 2, and 3 into 1. In this way, we can find out AB, and after that, transpose of this value is, this is the transpose of this value, minus 1, 4, 3, 2, minus 8, 6, and minus, this is the value. Now, A transpose and B transpose. So, A transpose and B transpose is, this is the value. So, B dash, B transpose and A transpose multiplication we have to do. And this is the result that we can see here. Both the result are same. This result and this result, both result are same. So in this way, we can find out the value of A transpose. This is the transpose value. Now, AB, this is the value, product of AB. So AB complement, this is the product of AB complement, A complement, B complement, and after that B transpose or A transpose. Once we will do, this is the multiplication of that value. Now, A equal to cos alpha, sin alpha, minus sin alpha, cos alpha, then verify. A complement A equal to unity matrix, and A complement A here also. A complement A equal to unity matrix. So both are same question. So one we can see here. A is given first of all, A is given. Now we have to find out, this is the value of A. We have to find out A complement. So A complement is nothing but cos alpha, sin alpha, minus sin alpha, cos alpha. This is the value. So A complement. Just when we will multiply this by this, we can do the multiplication, and this is the given result we will get. So final result is 1001. This is nothing but the unity matrix. And so that's why A complement A is always a unity matrix. This is proved. Similarly, A complement, here also do the same multiplication, and we are now very, very familiar with the multiplication of two matrices. So A complement, once we will multiply, this also get unity matrix. Question number 7. So that matrix A is symmetric matrix. And second, so that the matrix A is skew symmetric matrix. Now for the symmetric matrix, wherever the transpose, suppose transpose is equal to the given matrix, then this is called symmetric matrix. So whenever any matrix is given and after transposing the value, if we are getting the same result, then this is called transpose of this is called symmetric matrix. Now, skew symmetric is after doing the transpose. If we are getting the minus A value, that means minus of matrix value, then this is called skew symmetric matrix. This is very, very important, and for the objective point of view, this is very, very important. So A complement equal to minus A, this is skew symmetric, and A complement equal to A, this is symmetric matrix. So this value always you have to remember. For the matrix 1, 5, 6, 7, verify A plus A complement is symmetric and A minus A complement, A minus A transpose. Sometimes complement also we are telling transpose. So this is skew symmetric matrix. So A complement we have to find out, and just we have to add. So A plus A complement and A plus A complement of transpose is equal to the A plus A complement. So this we can verify, and this is nothing but the symmetric matrix. That means whatever the value of A plus A complement, we have to find out transpose. After doing the transpose, this is equal to A plus A transpose value. This is called symmetric matrix. So the originality of the symmetric matrix, it will not change. That means once we are finding out the A transpose, that is equal to the original value of the given matrix. So A minus A complement, we have to find out 0 minus 1, 1, 0, and A minus A complement, A minus A transpose of transpose, this will give the negative sign of this value, and this is equal to minus of A minus A transpose, and this is called skew symmetric matrix. Find half of A plus A complement, half of A minus A complement, A minus A transpose. The given matrix is, this is the given matrix. So A is this. So transpose of this value is, this is the transpose. So after adding A plus A transpose, we have to add this two matrix value is this. So half of A plus A dash, because this is zero matrix, so this value is 0. Similarly, A minus A transpose we have to find out, and this we got, this is the value. This is the value. So half of A minus A transpose is, this is the, so just we are taking half, and after taking half, we are getting this value. So this is the verified result. Express the following matrix as sum of symmetric and skew symmetric matrix. So this is the first question, second question, third question, fourth question. Now, symmetric matrix A plus A transpose. So A is given and A transpose is given. So A plus A transpose, first we have to add, this we got the result. So symmetric matrix is nothing but half of A plus A complement. Half of this is the symmetric matrix. So whenever the A and their complement, A complement is there, then half of A plus A complement is nothing but the symmetric matrix. This is half of A plus A complement is symmetric matrix. So P we took here, and symmetric matrix A plus A complement of half we took, then we are getting here this we represented as a P. So P complement is equal to P, that it is showing this is a symmetric matrix. Now A minus A complement, first of all, after that again this we represented as a Q, half of A minus A dash. So this value first we have to find out, and this value half 0, 4, minus 4, 0, and after doing this we are getting 0, 2, minus 2, 0, and this is equal to minus Q. This is equal to minus Q. So this Q complement once we Q transpose once we'll take, then this is equal to minus Q value. So just you can check here, this both the value are same but with the negative sign. So this is the Q, and this is the Q complement is equal to minus Q. So in this way we can tell half of A minus A complement is skew symmetric matrix. So sum of, so A as the sum of P and Q. So P plus Q, once we will find out, this is the P value and this is the Q value. After adding, this is equal to A. Similarly, second we can do A complement we have to find out, A plus A complement. After that, we have to represent, or this is the process, this is nothing but the process to finding out the sum of skew matrix and symmetric matrix. This is the two things. So this is the A dash, that is A complement we have to find out. This is the matrix we got. So this matrix that we can write in the form of 1 by 2 A plus A dash. So this is equal to P. This we can represent as a P. So after taking the transpose, this is equal to P. After taking the transpose, both value are same. After this is the P. After taking the transpose, that means this is the first row. Now this becomes the first column. This is the second row. This becomes second column. This is the third row. This becomes third column. So after doing this, both the value P and P complement both are same. So this P complement equal to P. So this represents a symmetric matrix. So half of A plus A dash is symmetric matrix. Always remember. So A minus A complement, once we will do. So this is equal to coming 0. So Q dash, that is Q transpose, is equal to minus Q. So this is Q symmetric matrix. So sum of P and Q, when we will find out, this is equal to A. Now A and A dash. Third question, A and A dash. So A plus A dash, once we will find out, this is the final result of A plus A transpose. So half of A plus A complement, that we are representing. Always this is the steps that always we are following for the symmetric, sum of the symmetric and skew symmetric. So first A plus A transpose we have to find out half of that value, that is equal to P, and after that half we are doing, and this is the resulting value. Now P complement we can do 3 1 by 2 minus 5 by 2, and this is equal to P. So this is P value for the symmetric matrix is half of A plus A dash we have to find out. So A minus A dash, same way we have to find out, and Q, this is equal to Q, and this is the value of Q, and Q dash is equal to minus Q, and this is all the process are same. So Q equal to A minus A complement, and sum we can represent P plus Q. This is the sum of the P plus Q. Fourth question, A and A complement. So A plus A complement, we can represent this. This is the value. So A plus A complement of half, this represent the symmetric matrix, and this is coming P. So we have to check, this is for the symmetric matrix, we have to check P complement is equal to P. So this is symmetric matrix. Similarly, A minus A complement we have to find out. So A minus A complement is, after finding out, this is the value, and this we are representing by Q, half of that. So this is the half, and we are finding out Q complement. Q transpose, this is equal to minus Q, and this is representing a skew symmetric matrix. This is the representation of Q, and as we have to represent the sum of P and Q, so P plus Q equal to A. Now question number 11 is very, very important. If A and B are symmetric matrix of same order, then AB minus BA is equal to what? So in this, we have to select the choice, skew symmetric, symmetric, zero matrix, identity matrix, which is correct, that we have to find out. So A and B are symmetric matrix. So one thing is crystal clear. If we will take the transpose that is equal to the given matrix, transpose that is equal to B. So A transpose equal to A, B transpose equal to B. So after that, AB minus BA, that we have to find out, and transpose of that we are taking. So AB minus BA transpose, we are taking AB transpose minus BA transpose, because A minus B transpose is nothing but A transpose minus B transpose. So always remember, this is the very, very important formula. Now, here we are AB transpose minus BA transpose, and we know this is the second important thing. AB transpose in the product format we are writing in the reverse order, B transpose A transpose. So AB transpose we can write B transpose A transpose minus A transpose B transpose. So this is equal to A transpose equal to A and B transpose equal to B. So based on that, we can write BA minus AB. So after taking minus here, so this is AB minus BA, and this is equal to negative of AB minus BA transpose, and this is AB minus BA transpose equal to actually minus AB minus BA, and this represents, this is skew symmetric matrix. If A equal to cos alpha minus sin alpha plus sin alpha cos alpha, then A plus A transpose equal to I if the value of alpha is equal to what? Now this is given, so A plus A transpose equal to I, first of all we have to write, and here once we are doing this operation, then this sum is equal to this, and this is equal to 1001. Comparing the element of two matrices, so 2 cos alpha equal to 1. So cos alpha equal to, easily we can write here cos 1 by 2. This pi is here, that is cos pi by 3. So alpha equal to pi by 3. So I hope this is crystal clear for symmetric and skew symmetric concept, major involvement of symmetric and skew symmetric. This is very important concept of the matrix. So just you do the practice and command on this exercise. Thank you.